Hello, CIS40A. In this video, we are going to cover the last part of our notes, which is going to be on 802.11 standards for wireless. And this is part 3 of the lecture video. And in this part, we are going to also answer the last few questions. So for the 802.11 standards, it was originated in the late 1999s, in which your wireless LAN was incorporated for um, organizational use, along with looking at the frequency, which is 2.4 gigahertz radio frequency back then. So the first few that was developed, 802.11a, the transfer rate for that is 54 megabit per second, and it uses 5 gigahertz standard. So definitely faster in the speed, but shorter in the range as far as distance range. And so for the wireless access point, the WAP, the devices then would be able to connect to the wireless access point, and the wireless access point will be able to forward the data to the rest of the network. However, in the 802.11a, it's only compatible with the devices back then for 802.11a. And wireless devices were a little bit more rare at that time. So in the following years, we would have 802.11b, which was using 2 gigahertz frequency, and the transfer rate for that is 5.5 megabit per second and 11 megabit per second. Then in the subsequent year, there were development with 802.11g and before the AC. So on the page 16, you would see a list of different 802.11 standards, but not all were implemented for commercial use. So G was compatible with A, where B, because as you can see with the speed, and also G was compatible with B as it is on the same standard, whereas A was compatible and has backward compatibility with A, and B and A are incompatible. So what does that mean? When you have certain devices that was classified for under certain 802.11 standards, it would not work with some of the standards outside of its scope. So some were backward compatible and some were not. So when we're looking at the 802.11n, at that time we would then implement MIMO, which is the antenna that's able to send and receive. So you would have multiple antenna at that point. So as you can see on the chart, it provides you with different 802.11, and in the description here, the B, the maximum data rate was 11 megabit per second at that time. It was widely adopted after A. And so with B, you have CIS40A, which is used to be able to look at send requests and clear to send. So with that, we would have a way to acknowledge that there is send or communication with the system. So the host must communicate with the access point, and the access point, once it acknowledged the host, then the packet can be sent. So CIS40A was implemented for that, and as you can see, this is also an illustration for that. 802.11g standard was ratified in 2003, and it would be compatible with B. So G is backward compatible with B, and it's able to provide 54 megabit per second as maximum data rate. Now it runs on the 2.4 gigahertz range. So 802.11b is compatible with 802.11g, meaning that G has compatibility with the devices that was classified under 802.11b. So if I have a laptop that uses the wireless adapter that was classified under 802.11b, and I'm trying to connect to the router that is 802.11g, that router should be able to work with that laptop. So it should be able to communicate with that laptop with the capability of the backward compatibility. Okay. So it provides you with information on the cards and how that would be. And in the United States, there are 11 channels that's configured under the 2.4 gigahertz frequency. Channel 1, Channel 6, and Channel 11 are non-overlapping, which allow you to have 3 access points. So this allows you to have 3 access points in the same area without experiencing interferences. So 1, 6, and 11 would be non-overlapping. So you must aware of the channel so that way your access point cannot be overlapping. So if you configure access point with the channel 1, then the next access point you would then need to configure it at 11 or a 6. You cannot have a 1 and a 1 across because these channels are non-overlapping. The other channel 2, 3, 4, 5, 7, 8, 9, 10, 12, 13, 14, those channel on the 2.4 gigahertz frequency can be overlapping. And so for your access point, we don't want it, if we don't want it to be overlapping, then we want to configure it as different channel 1, 6, or 11. On the 5 gigahertz, we would see 802.11a, and this was one of the first standards that was implemented for wireless. This was established in 1999. And so when you look at this, even though it's on 5 gigahertz, the distance from one device to the router would be limited, as it would give you higher bandwidth, but at the same time you are limited to shorter distance range. And the throughput for that would be 54 megabit per second, and it has 12 non-overlapping frequency. So none of the channels are going to be overlapping. So you would have a lower band that would be for indoor, the middle band that will be indoor and outdoor, and the upper band that will be mainly used for outdoor. So 802.11a is immune to interference because such as your microwave ovens, your cordless phone, and your Bluetooth devices, such that it operates on a non-overlapping channel. So for 802.11a, the products were operating at 54 megabit per second and also shift to 48 megabit per second, and less than that 36, 24, 18, 12, and 9. And so the farthest access point will be communicating at 6 megabit per second. For 802.11h, this was established in 2004 and later 2008. And so these channels were able to utilize what was created from 802.11a. So there are 23 non-overlapping channels for 802.11h, and there are new features that were added to 5 gigahertz compared to what you've seen from 802.11a. H was never really fully implemented for consumer use. However, here it would give you some information about 802.11h. On the dual band, we would see that at the end of the era for 802.11n, and this in 802.11n is where multiple antennas were being implemented or used in the router, which is known as multiple input and output, which is MIMO. and sometimes referred to as smart antenna. So multiple input and multiple output allows several frames to be sent to several antenna at the same time. So that way it would optimize the throughput for multipath. And on 802.11n, since there are dual bands, two frequencies, 2.4 gigahertz and 5 gigahertz, there is something called channel bonding. So for the 5 gigahertz, you would see 20, 40 megahertz, and 80 megahertz. So for the 40 megahertz channel, that would also be used on 802.11g and A. 802.11g and A, I'm sorry, 802.11g and A uses 20 megahertz, and for the 40 megahertz, that will be on the higher scale. So 802.11n aggregates for at the speed at 54 megabit per second at 100 and to 108 megabit per second at the 40 megahertz channel. So for the efficiency for 802.11 protocol, this required frame-by-frame acknowledgement, and 802.11n can pass many packets before acknowledging it, which saves overhead and it's able to have faster throughput. So that was one of the first 802.11 standard that actually break the barrier of just 54 megabit per second. So it was able to go higher. And in the next part, it talks about Wi-Fi, and Wi-Fi just stands for wireless fidelity. And so the products that were implemented was under the classification of 802.11. And for the consumer, that will be A, B, G, N, and now AC. So that brings us to 802.11 AC, which is the current Wi-Fi standard. It uses 5 gigahertz and 2.4 gigahertz bands. It's able to give the throughput of 500 megabit per second. So in such sense, it also have higher frequency as far as for channel. So you would have supported with 160 megahertz, and in the prior classification, it was only up to 80. So now we're able to double the frequency for the channel in 802.11 AC. So here gives you the comparison between 802.11b, G, N, and so on. The progression for that would then be gradual, even though G was able to expand further, but then you would have less of the transfer rate. So when I have a device that's 300 feet away, and if I'm using 802.11g, I would only be able to transfer at 6 megabit per second. But in the same classification, if I have a device that is 50 feet away, I'm able to have more throughput using that particular standard. So for the 802.11a was 200 feet for 6 megabit per second. And when you are under 100 feet, that will give you 54 megabit per second. B is going to give you a little bit slower in the speed. However, the distance would be longer in that it uses 2.4 gigahertz instead of the other two where it would use 5 gigahertz. So that gives you a little bit of a summary of how we would look at 802.11 classification for the standard. So now for number 21, it asks you which wireless IEEE 802.11 standard has transfer rate of 11 megabit per second and it was widely adopted. That will be 802.11b. So the original rate was between 6 and 11 megabit per second. For number 22, it asks you which wireless IEEE 802.11 standard has a transfer rate of 54 megabit per second and has backward compatibility with 802.11b. That will be 802.11g. Even though A has 54 megabit per second transfer rate, it is one of its first, so there's no backward compatibility with A because there's no prior standard to 802.11a. So the answer for 22 would be 802.11g. And so you can check out the notes in the chapter. My notes are compiled a little bit different than what the chapter had. I had added some additional materials to show you the difference between the standards. It's important to know 802.11 standards, 802.3 standards, and 802.5 standards for the Network Plus certification and also for our quiz and exam. So this concludes my video for part 3, which covers 802.11 standards, which is wireless. And thank you for watching this video.